Hi, welcome back to Intermediate Algebra. Today we're doing section 6.4, multiplying and dividing radical expressions. So basically we're going to start multiplying things that have roots in them, square roots, cube roots, fourth roots, that kind of thing. It's going to be fairly straightforward. Really is. You're going to do a lot of things that you've seen before here in this section. The only difference is we have to actually figure out what does it mean to take two square roots or two cube roots and multiply them together. But as we're going to see, it's going to be pretty nice. So I've got a few things here on the board, and then we'll start looking at some examples and some of the messiness that we will still see here. All right, so first thing we have to know is they have to have the same index. So just a reminder, the little number on your radical is the index. In this case, I have the 4 through 7, so 4 is the index. You cannot multiply radicals together if they don't have the same index. All right, that's not so bad. All right, 2 is really kind of the key here. We have a property for radicals that says if you multiply two radicals, again with that same index, I'm using n here just to kind of be generic, that we can just multiply the two things that were on the inside. So you can see I took my two radicals and I shoved them back together into one with multiplication on the inside. And so as an example, I have the square root of 2 times the square root of 6. We know that 2 times 6 is 12. And so I did my multiplication, and there we go. We have the square root of 12. The last point here that we really need to consider with these is that we need to simplify when we're done. In that previous example where we got an answer of the square root of 12, if you do your factoring, 12 is equal to 2 squared times 3. And we know that we can't have any exponents on the inside that are equal to or greater than the index. And so since my index here is 2, and I have an exponent of 2, I need to do the work to simplify that, pull that 2 out, and so we get 2 times the square root of 3. If you need more help working with simplifying the radicals, go back and watch the video from, I think, the last section, and make sure that you know how to simplify radicals. So we're going to start looking at some examples, and really everything we do here is going to basically going to follow this process. We'll throw a few little things in there to make it messier and a little bit less fun, but generally speaking, it's going to work like that. So give me a second, let's remake the board and we'll do some more. Okay, so I have a couple more examples here that we're going to look at, and then eventually here we're going to get into dividing with these things. It's going to be kind of fun. So my first example is this one, 3 times the square root of 5 times 4 times the square root of 6. And I like to think that this probably works exactly like you probably think it should. But basically, all we're going to do is we're going to take the coefficients, the 3 and the 4, and we're going to multiply those together, and that gives us the 12. And then we're going to take the radicals, 5 and 6, 5 times 6 is 30, and that's it. We did the 3 times 4 to get 12, we did the 5 times 6 to get 30, and we're done. That's the whole problem. And so that's a little technique we're going to see a lot of here. When you have coefficients in front of these radicals, you just do them as two separate parts. The coefficients get multiplied, the radicals get multiplied. And so that hopefully will work out pretty well for you. All right, so then next I have a bigger, uglier, messier looking problem. And yeah, there's really no getting around that. And it won't be the last bit of nasty we see here. We have parentheses, square root of 2 plus square root of 5 times 4 square roots of 2 minus 3 square roots of 5. So the good news is this is just foiling all over again. You're going to take everything in the first set of parentheses times everything in the second. The bad news is that's kind of got a lot of pieces and it's a bit messy, so you're going to have to be really careful. So you'll see here that I wrote out all 4 pieces of multiplication. I have the square root of 2 times 4 square roots of 2. I have the square root of 2 times a negative 3 square root of 5. I have a positive square root of 5 times 4 square roots of 2 and square root of 5 times negative 3 square roots of 5. So I'm breaking it down. I'm writing out each of these pieces. Now, if you're taking my class, that's super important because you're showing work. And if you show work and something goes wrong, I can try and find what happened, and if it's just something kind of boneheaded, I can give you a lot of partial credit for it. Okay, so show me what's going on. Don't just try and skip all the way to the end of the problem. That's never a good idea. So I have all my multiplication written out. It's kind of little, so hopefully you can read it. And when I multiply, one thing to remember here is this. Anytime you multiply two square roots together that are the same, you just get the thing on the inside, right? Square root of 2 times square root of 2 is just 2. And that happens down here again with the square root of 5 and the square root of 5. They combine to make 5. So just keep that in mind. If you're multiplying roots together that are square roots together that are the same, you just get the thing on the inside. So I end up with 4 times 2, and then if I do the multiplication here, I have 2 times 5 gives me square root of 10. So minus 3 square roots of 10. 5 times 2 is, ooh, hold on. Well, that didn't work out right. Let's try that one again. 5 times 2 is 10. I multiply the wrong things together. Don't do that. Bad plan. And we have a 4 in front. And then, of course, the 3 times 5. Cleaning it up, 4 times 2 is 8. 3 times 5 is 15. So I have a minus 15 at the end. Oh, I need to fix this again. See, now this is why you don't make mistakes when you're teaching. It's just a bad plan. 4 square roots of 10. And let's finish this one off too. Plus square root of 10. All right, anyway. So there we go. I combine my like terms. 8 minus 15 is a negative 7. I have like terms here in the middle as well. Right, I have a negative 3 times the square root of 10 and plus 4 square roots of 10. Those match. We can add them together. We get a just plus 1 or just plus square root of 10. So there we go. That was fun. It's always embarrassing when I make a mistake. All right, so let's go on and let's try some more. All right, a couple more examples here, and then we'll move on to dividing. That's always fun. So, first example I have square root of x plus 2, and I have that whole thing squared. Okay, so one big thing to watch out for here is you cannot take an exponent across addition or subtraction. So a lot of times, and I'm not even going to write it down because I just don't even want to see this, it's just really wrong. But a lot of times people will square both of those and tell me that the answer is x plus 4. Unfortunately, that doesn't work. The reason it doesn't work is because remember when you square something, you are multiplying it by itself. So in this case, I have the square root of x plus 2 squared, which means I'm multiplying those two sets of parentheses, multiplying it by itself. I have a whole lot of multiplication to do, which you can see I wrote out. So we have the square root of x times square root of x, square root of x times 2, 2 times the square root of x, and 2 times 2. Clean it up. Again, we're multiplying square roots together that are the same, so we just get the x. X square root of x times 2 is 2 square roots of x, and 2 times the square root of x is 2 square roots of x. And then 2 times 2 is 4. I can combine those like terms in the middle. 2 and 2 make 4, so I get x plus 4 square roots of x plus 4. But again, please be careful. A lot of times people just square the parts, and that doesn't work because if you do, like I said, you get x plus 4 when you square those two things. Look, we have an x, we have a 4, but there is also this middle term that we have to have. Otherwise, it's just not right. So please be careful with that. So the other thing I want to talk about here on this board is what's called conjugates. So conjugates are when you have the same two things in both sets of parentheses, but one has a plus sign and one has a minus sign. And so we're going to see this time and again. It's going to come back in section 6 when we do complex numbers. But here we see it. And what's nice about conjugates is, if we do the work to multiply this out, root 5 times itself gives me a 5. Root 5 times negative root 3 gives me minus square root of 15. Root 3 times 5 gives me a positive square root of 15. And root 3 times negative root 3 gives me minus 3. And notice what happens here. After I do that, the two middle terms are opposites of each other. I have a negative square root of 15 and a positive square root of 15. And they're just going to knock each other out. Okay, one's positive, one's negative. They are otherwise the same, so they combine to make 0, which just leaves me with a 5 and minus 3 for an answer of 2. And so anytime you multiply conjugates together, you will get just a nice, normal-looking number without any radicals in it. And that's going to be super useful because that is how we're going to do this with division. So hang on, let me change the board, and we'll look at division. All right, so rationalizing the denominator. We can do this, well, let's start over here where I should be. Divide and rationalize the denominator. We're going to multiply the top and bottom by the conjugate of the denominator. So I have an example, and really that's the only step. Multiply the top and the bottom by the conjugate of the denominator. So it's one step, but it's going to be a bit of work. So here's what I have. This is a pretty simple example because on the top I just have a 4. Definitely nicer when there isn't even more of a mess up there. So I have 4 over the square root of 3 plus the square root of 2. So again, we said this before in a different section, we don't like having radicals in the denominator, so we're going to get rid of them. Unfortunately, I have 2 of them and they're connected by addition. We'd have the same problem if they were connected by subtraction. So in order to get rid of them, we're going to multiply the top and the bottom by the conjugate of the denominator. So remember, a conjugate, we just change the sign in the middle. And we can do this if we have two radicals. I can do this if it was 3 plus the square root of 2. If there's one radical down there, we can just multiply by the conjugate and that'll work. So let's see. I do that on the top, I just have 4 times those parentheses. On the bottom, I end up getting 1. So my answer is 4 over the square root of 3 minus the square root of 2. But for the bottom, I wrote all the work that I did down here at the bottom of my board. So you can see I have my multiplication written out. I have root 3 times root 3 times negative root 2 times root 3, and root 2 times negative root 2. And when I do that, again, if you multiply 2 square roots with the same number on the inside, you just get the number on the inside. So I get 3, I get a 2 at the minus 2 at the end, and in the middle I get 2 square roots of 6's, but one's a negative and one's a positive, so they go away, just like we would hope. And that's how I got 1. So there you go. That's rationalizing the denominator. It's really just more multiplying. I know you can do it. Hang in there, do the work, and we'll get through this. So thanks, and have a good day.